Okay, so you've seen an introduction to the idea of taking the ratios of two consecutive Fibonacci numbers and dividing them out. And you've noticed from what Ed has said, it appears they are approaching something, all right, about 1.618. Well, I thought it would be kind of cool if we took a look at this a little more carefully and got into some much bigger Fibonacci numbers. So if you'll pull up your sheet, group work 5, or if you've printed it, and if you have it next to you or near you, that would be great. And grab your calculator, because I'm going to ask you to do some computations involving these ratios that are right next to each other. But to save you time and to save you the hassle of writing all this stuff out, okay, what I did is I wrote it all out for you here. As you can see, I have the Fibonacci tables up here, all right? But notice what I've done. I've gone to higher level Fibonacci numbers, okay? So what I have done is I've gone here to F15, the 15th Fibonacci number, 610, and we're going to divide it by the 14th, 377, and we're going to see what happens. So, and I've done this, as you can see down the page, and you can see it, of course, on your sheet, and I've even gone up as high as the 28th Fibonacci number divided by the 27th Fibonacci number. Okay, so here's what I'd like you to do, okay? Would you just take a second, please? Take your calculator, all right? And let's go, let's say, to this one right here. Would you take the 18th Fibonacci number, which I've already written down for you, is 2584, and divide it by the 17th Fibonacci number, which is 1597, okay? And if you do that, okay, and divide that out, I'd like you to write your answer correct to 7 decimal places, but you don't have to write it out. You don't have to round it off, excuse me. Just write 1.618 and then the rest of the decimals. Now, I'm going to assume you've done that. Now what I'd like you to do is go right across the table to this one, Fibonacci number 25, and I'd like you to divide it by Fibonacci number 24. So you're going to divide 75,025 by 46,368. Go ahead and do that and see what you get. Write it down to 7 decimal places, right above this arrow, right in this area or arena right here. And now I'd like you to go down here and do these two numbers, okay, these numbers, 196,418, which is Fibonacci number 28, and I'd like you to divide it by Fibonacci number 27. I'm sorry, that's not right. I want you to do it down here. If you're doing that when you're getting the answer that goes up here, 27 divided by 26. If you've already done that, what I want you to do is this last one, 317,811. And if you divide that by 196,418, let's see what you get. Notice it's 1.618, and it keeps on going for 4 more decimal places. And of course, the number continues to go on forever. It never stops, okay? But you can see we're approaching something, right? Okay. Now, here's what I'm going to do, okay? I'm going to go to the page that you have here, but I'm going to show you the page with all the answers in it, all right? I want you to notice that the answers on the left are varying just a little bit, right? But all of a sudden, when you get down to F20 divided by F19, F21 divided by F20, and so forth, you notice the 7 decimal places the answers are all exactly the same. Look over here on the right. You can see the answers are all approaching this crazy number, okay? Kind of strange, huh? But not really. Okay, so you get the same answer to several decimal places really without rounding here. You are asked to get the same answers. What I'm saying is you are asked to work them out and get the answers, and notice they come out exactly the same, particularly to 7 decimal places. They aren't exactly the same though, really, because if you go out 25 decimal places, the numbers would be different. But we're not going to go out there, okay? But you can see we're definitely approaching something, okay? Now, gosh, you know what? The Luca numbers that we've discussed that start with the seeds 2 and 1, I wonder what happens with them. They're built, that system of numbers is built the same way. You add the 2 previous numbers to get the next one. I wonder if it does the same stuff. I wonder if it approaches something. So here's what we're going to do. If you flip your sheet over to the back, okay, I have the Luca numbers written out starting at 15 divided by 14. Luca's 22 over here divided by 21. So let's just do this. Take a minute right now and take this one right here, Luca 17, and divide it by Luca 16. So that's 2207 divided by 1364. And see what you get for an answer. Let's go across the table like we did before. Let's go down here to 103,682, this one right here. Luca 25 divided by Luca 24. 103,682 divided by 64,079. And just for the heck of it, write that answer down to 7 decimal places, just like we did for the Fibonacci's, okay? And if we go to the very last one down here, 28 divided by Luca 27, you are dividing, I'll read it to you so you can put it in your calculator, 439,204, and please divide that by 271,443. Just like I did before, I'm going to show you the answers to all of these worked out to 7 decimal places. So my next sheet right here is all the answers. Unfortunately, it's kind of crooked on here, but there they are. And notice something. Don't these look familiar over here? As we got up finally to Luca 20 divided by Luca 19, we got pretty close to the answer we got on every time on the other side. By the time we got to Luca 22 divided by Luca 21, the answer was 1.6180,339 every single time they're beyond there, okay? So it appears that the Luca numbers, if you divide consecutive Luca numbers, they do exactly the same thing. They approach this crazy number, this 1.6180,339. Now, this number that they're approaching, we have given a name in mathematics. All right, it is called the golden ratio. The golden ratio. And it is referred to by this strange looking symbol here, which is called phi. You recall that's phi from geometry and other problems you've had in mathematics before. You've seen phi before. So phi rounded off to 6 decimal places is 1.618034. Okay, now that appears to be what it's growing toward, okay, written to 6 decimal places. But I'm wondering if there is an exact value for phi. Well, Dr. Mike is going to talk, or excuse me, Dr. Ed is going to talk to you about that. Now, I will never ask you to recreate what he's about to show you. It can be rather confusing, but I'm going to let him show it to you, and then I'm going to show it to you also afterwards. And then hopefully you'll have an understanding at some point in your life, if any of your children ask you about this, that you will know how we got this magical number phi. Okay? So I'm going to go on now and let Dr. Mike, all right, continue talking about, okay, talking about what we're doing here in dividing these numbers and what we're approaching. And he will tell you the exact value. So I'll see you shortly.